Okay, for this week we're going to be talking about mostly other packages. So, as I mentioned before, one of the really powerful things about Python is all of the different packages, also called libraries, that are available for it. Before we dive into that, so we're here in week 10, I'm going to talk a little bit about design. We touch on design periodically throughout the class, but this is a beginning software development class, so we don't get into too much detail. I do recommend looking at this in the future, especially if you're working with large software project or spend the bulk of your time doing programming. Definitely look at design, because design expertise is the thing that keeps a project from becoming a nightmare to work on. In other words, as your projects get bigger, the amount of code that you're managing gets larger, you need to be constantly reorganizing, redeveloping it, and hopefully at the front you do some real design work. And these are some of the methods that we use to do software design. User flows show how the user moves through the software. Control flows are which objects are in control. This is especially important for complex processes like processing a lot of data. Data flows show how data flows through the software. We do this a lot when we're working with virtual environments, the internet. And then hierarchy diagrams, we tend to pretty much organize all of our software into hierarchies, and I'll talk a little bit more about those in the near future. And then there's also other tools you need to have. So which development environment you use is absolutely critical. I really like the Wing environment. The source code versioning system, SCV I think it is, from Microsoft, looks pretty good as well. A little bit harder to get into than Wing because it's not specifically for Python, so I don't use it in this class, but I think it's a good solution. But then you also need source code control. As soon as you have multiple people working on a project, you want to have some system for controlling your software. GitHub is the most popular. I disagree with the model they're using. I like a library model where you can check out code and check it back in, but it is the one that's the most popular by far. A defect tracking system is tracking the defects. So you're now a developer. So I'm sure you've been annoyed in the past where you found a bug in a piece of software. We call those defects because they're problems that need to be fixed. And nobody ever did anything about it. Like, the bullets in Microsoft Word that have been messed up for 10 years and have never been fixed. Someone needs to record that as an issue or defect and then track it over time and make sure it gets fixed. And then test management, testing the software to make sure that it does everything that it promises and works for the user, is again key to good software development, design, and keeping your users happy especially. One of the areas I specialize in is user interface design, or did in my previous life. GUIs, I did those specifically for scanners at Hewlett-Packard and led that effort. These can get very complicated very quickly, as I'm sure you know, and keeping them simple and intuitive and effective is a challenge, but I think it's a lot of fun. There's a lot of good work that can come out of that. All right, so libraries and packages. There are a ton of libraries and packages for Python, as I've said. Just within the Python standard library, which comes with Python, there's a huge number of packages. We haven't even started to get into the large number that are here. We've worked with math, we've worked with random. You can see there's even a number of other math packages, all kinds of things. We've worked a little bit with files and directory access. Data persistence allows you to save and load data. There's SQLite, which is a database interface. You can unzip and zip things from Python. Here's some file formats. We've worked with CSV. Cryptography, being able to encode things like passwords. We've worked with OS, but you can see there's just a huge number, and these are all standard built-in, come with. There's URLlib that we've worked with that come with Python. There is a graphical user interface here, tkinter. It's really out of date, so I don't teach that anymore. I used to, but it's old, and the GUIs that it creates look old, so that's why I switched to PyQt. And that's part of the real key to working with libraries and being happy with them, is how you pick the right library. This would be one of the first places you'd go, is all of you should want to take a look at this page, see what's there so you're familiar with it, because those are the standard libraries. Usually you would want to use those before you go into something else. Okay? These libraries are all stored in a folder called lib/site packages. So site packages were additional libraries. So the standard libraries are there, built in, and then as you add new libraries, they go into site packages. And this is something you'll just do as a Python programmer, is manage the libraries that you use. Bindings, you'll hear people talk about bindings for Python. So there's a lot of libraries that are out there, like ArcGIS has all this software that's actually originally written in C++, but you can create a binding. In other words, a binding is an interface so that you can call a program that's written in a different language from Python. And it's one of the things that makes Python easy to create libraries for. Okay, external packages. This is really where the fun and the pain is. I'm going to go to the Python package index. This is a place where you can find all kinds of different packages for stuff, like let's check out GIS. There's 527 projects for GIS, and these are the ones listed on the Python website, pypy.org. Yeah, it's not python.org. It's another website we got bumped to that manages the Python interfaces. But there's a lot of these. These are not all the ones that are out there. These are the ones that they're serving up. 500, how do you find what you're looking for? Well, you'd want to be more specific. So like shapefile. Now, there's 165 shapefile libraries. Wow, just a lot of stuff. And some of this is going to be really good stuff, but actually finding the one you want can be quite a challenge. Also, if you look at other things, I've had students work with sound, over 1,000 with sound. If we type in map, 8,000 things that work with maps. Oh, look, that one looks like it's in a different language. Cool. Python is international, so it's very popular overseas, and you'll see a lot of other languages used, and especially in the blogs when you're talking to folks. Most of it's in English, but you'll see other languages pop up. Okay, so the real challenge is how to find it. And the way you really find those is not by going through package index, it's by the blogs. It's, by going to a blog and saying Python shapefile, PyShape. Suddenly the number one hits is the most popular library for reading and writing shapefiles. Boom, we're there. Okay, this is how you want to find things. Now, usually it won't be quite that quick. You'll need to do some work going through blogs and folks talking about it to find the one that you really want, the best one for what you're doing. Okay, so there are some standard ones that we'll play with. NumPy, SciPy, very commonly used. Matplotlib for plotting. Fiona's vector shapefile and data.io. Shapefile Plus, kind of. And then Shapely supports things like polygons, polylines. GeoPandas links these together. One of the things that I keep hoping for is to get and I should say, these are all open source. These are all free. Just go download them. There are Python libraries that will charge you money. You'll see that when you go to install them, or they'll give you a free period. But those aren't really common. Most of the libraries for Python are available for free. Also, a lot of companies will provide you with a basic library, and then there'll be a more advanced one for a charge. Okay, so we'll talk a little more about these in a sec. The real issue with Python is installing these. And this has gotten better, but it's still kind of a nightmare. And one of the issues is you start installing them, and then they'll start having conflicts with each other. And that's really the hard part. But first step is just getting them installed. Anaconda is a software system that was supposed to solve all the problems with installing Python packages, and it worked really well for a while, but then it failed to install some packages that I needed, and that was it. You can't install into Anaconda's Python, or you're not supposed to, without going through Anaconda. So I was kind of stuck, and so I have moved away from Anaconda. The provided installers, these are the standard installers that come with Python. There's two, easy install and, provided installers. This is kind of coming outdated, but it still does happen where inside of the package, you'll download it, there'll be a zip, and then inside there'll be a setup.py. This is how we used to install most of our packages. However, nowadays we tend to use easy install and pip. So pip is the old installer. You type pip, install, and then the name of the package, like SciPy. Now, it's important to run this from within the scripts folder of the Python installation that you want to have the package added to. One of the issues is we tend to end up with multiple versions of Python, multiple different, like 2.7 for ArcMap, 3.7 for ArcGIS Pro. We might have another install of 3.7 for our own use. You want to make sure you bring up the command line, go down into the Python install, find the scripts folder. In there will be pip, and then I run these from there so that I make sure I'm installing it in the right version of Python. Easy Install used to come with a set of setup tools that was a pain to install. Kind of funny. Now it's included with Python. It does basically the same thing as pip, so I tend to run pip, but Easy Install just takes out the word install. Both of them run, I think, pretty much the same way. They go out on the web and they will download the latest version of a package that works with your version of Python. However, they do not always work. They seem to be getting better. We've had more luck with 3x, but when you get stuck, there's this guy, Christopher Golk. Not sure how to pronounce his last name, but we should give out a shout to Christoph, because for years he has maintained this website with all of these installers. Now for PyQt we use pip because he only has PyQt 4, and this might be something that goes away if the other installers work, but there's NumPy. And then you just go down and you do have to pick the version of Python. So, notice here it says 3.8, 3.7, 2.7, 3.7. That's the version of Python. And then the version of operating system. So we're on AMD 64. That's 64-bit Windows machine. Here's a 32-bit Windows machine. So most of us should be on 64. So if I was using 3.7 as I am at home, I would install this one. It's called the wheel file. And up at the top, he has instructions for how to use these. This has actually been the source that I have been the most successful with every single library that Christoph supports here. So this has been an amazing resource when I get stuck and can't get things installed. All right, so you have to pick how you're going to install them. I recommend going first with pip and easy install, and then when those break, go to Christoph's page, and that's how I've been doing stuff for years. And every once in a while you get stuck and it's frustrated, but give yourself some time to get these things working. All right, and I'll come back.